We're going to be going back into our roles here where I'll be the developer. In this case, I'll be driving the demo, so I'm doing the backstage development, looking to Shane, our infrastructure architect, to help me guide through a little bit of Digital Rebar and mostly answer questions about how to consume the Digital Rebar API. Hey Shane, I've made some progress with this backstage integration that I'm trying to do, but I need your help.
Okay, what can I do for you today, Rob?
So here I've set up my own backstage developer environment.
Okay.
Right, it's all this Node.js stuff. It's working pretty good, and I've been able to connect it following RackN's demos into my Digital Rebar system.
Okay.
So over here I have, this is my backstage environment. This is my Digital Rebar environment with the clusters, and somebody's already created this context thing that's sitting in here, and I've gone back and I can see it. So I know I'm pulling data out of Digital Rebar, and that's all good.
Great.
But then I went in to create a new cluster using the backstage scaffolding, and when I went to do that, I built this little template. I put in my my first demo. So I have my Cloud Field Day 17 cluster. I'm going to go build that, take it through. This is pretty cool. Like I didn't have to write much code. There's already an API that RackN exposed with the Node.js pieces. So I just had to write some scaffolding, and it looks like it's working. But over here, when I come back to the clusters, I don't get any machines at all in this cluster. It's just the name, and there's nothing else.
Okay. Well, let's take a look at your front end code then.
Okay. Here is my front end code with my cluster, and I'm coming in here and I am just giving it the name of, this is not the right form, this is the right form. And so here's where I'm building that cluster, and I'm just calling create. There's this Digital Rebar clusters create code that calls the backend API, and I give it a name. And that's working, but Digital Rebar is broken because it's not actually doing anything.
Okay, and so is that parameter name being passed into DRP's API?
It is. So the thing, so clearly in here I'm missing something like the machine, the number of machines. Like, how does Digital Rebar figure out how many machines I'm supposed to pass in, or where I'm supposed to get them from?
Yeah. Those are just API field values on the API call. So you need to be able to add those into the front end code.
Okay. Let's see. So something like, sorry, the and I have to find my, there. All right. So here, let's expand this a little bit. So instead of just taking the name of the system, probably going to need the context broker.
Correct.
That's in here.
Yes.
And then I'm going to provide it the count. So but this is just going to drive the form. So down here, what you're saying is I need parameters to make all this stuff work. So I can provide this extra information into the API. So the broker name is coming back in here. So this is going to get that broker field and the count field. So if I pass those in, correct, let's try that, then I'm all of a sudden I'm going to have the right broker.
That provides the customization for the context broker to be able to create those resources.
All right, let me try that. So here's the name. Let's try second attempt. Call it just second. I've got context broker. Is that a good broker to use for this? It's a good test broker.
Yes.
Okay.
Is it context singular or plural? It's singular, yes.
And then I'm just going to pick 3 machines. Is that, because this is right, what we want to do is for my team, they just want to be able to name a cluster and then pick it and go. So I'm going to try and go ahead and see what that happens. Once again, look at that. Clusters created. We're done here. So here's my second cluster. It's still not, like, I know that if I go in here and add this sample cluster, if I just build a sample cluster and I pick the context broker here, great, count 3. all that looks great. I can hit save, just like I just did with Backstage. And now, but it's doing all sorts of stuff.
Correct. And that's the universal application or the pipeline that starts the build process.
Oh, so I have to not just ask for a cluster, but I have to give it some work.
It has to give it some work.
Oh, okay. So let me see if I can fix that in here and go back and do that. So in this case, what I want to do is I have the same type of thing. Here's my broker, here's my count. My team has really wants us to track who the owners are and figure out who actually made the request. And then, so in here, it looks like I need a lot more information. So I'm going to pass in that owner, but I'm also going to say, hey, wait a second, when I destroy that cluster, I'm going to tell it what to do when I tear it down.
Correct.
That makes sense.
That's the decommission process.
And then when I start it, I'm going to start that universal workflow, and then I'm going to start this base cluster. So that's the pipeline.
That's the pipeline we're talking about.
Okay.
Correct.
And then I decided, sort of for fun, I'm going to go ahead and give it an icon so I can help you identify what they are. That makes sense. But that's not that much more information, but it's literally getting it on the front, on that front process. So let's see if this does better. So over here,
create our third.
Create a third. I'm going to choose that one, and I'll just call this one third. Put myself in as the owner. Go ahead and let it create. So it still looks pretty much the same here. That was great.
Go back to the portal. You'll see if you're getting the machine resources.
Oh, okay. So this one now is going through and doing that cluster. If I click in here and look at machines, now those machines are coming up online.
Yep.
Okay. And the cluster itself is waiting until all that's finished. So I actually know that this system is when it's complete or not complete.
Goes back to your conversation earlier, how you were saying you can create clusters that are a holding place for work to be done. So we need to first create that cluster, which is that first step, and then you configure what you want to do with that cluster. And part of that configuration is the machine allocations and then defining where the machines are driven towards that pipeline.
And so these are mistakes. Can I just delete them over here? Let's see, take out that CFD, these busted ones.
Yes.
Okay, so if I did that, this would be like a garbage collection. Those don't work. If I come back over here, oops, I forgot to hit refresh.
And then
here's the ones. Those never showed up. These are the other ones that we've added.
Correct.
Okay. That's cool.
So you have control both from your developer portal as well as administrative control from an operational perspective on our side to clean things up when necessary.
This is really handy because in this thing, I can actually determine what workflow and additional parameters that are getting set and not have the developers have to worry about it. If it always needs this token or some additional information, I can push it in as part of the scaffolding, and then it'll just get pulled into.
Just like the previous work we've done, you can inject customization to add layers of customization on top of the base platforms and base pipeline that you drive the resources towards. So you have control over delivering a fully finished product through one automation framework.
Cool. Now, if I want to resize it, what do I have to keep in mind for resizing? Can I just go ahead and pump up the count? Like I can go in here and make this go,
but it's probably not going to work because you need to reevaluate the cluster. So you need to ensure that your front end code is going to reevaluate the cluster and rerun the workflow, pipeline workflow after you've applied the count change.
Okay. So from that code perspective, I would be looking at something where I don't know where that code disappeared to. Here it is. So in that case, what I would be looking at is some code where, let's see, where's my resize code? Here it is. Oh, I'm in the wrong spot. So from that code, what I'd need to be, this is back-end code for Backstage.
Correct.
And so from this, in this case, what I need to do is not just change the parameter size, but I'd also need to issue a resize. I've changed your information command.
Correct.
Which is based on a work order.
Correct. A work order gets run, and then the blueprint specified in that work order tell the back-end system to reevaluate the cluster, And then that reevaluation will take into accommodation the size count that you specify on the front end.
So let me give that a shot. If we go in here and I'm changing this to 6, now if I went over to Digital Rebar, this now has a queued up work order where it's doing that process now. So it didn't just change the size without
Correct.
fixing anything. It's actually running that process.
And then if you look at your machine counts, you should see those machines
Oh yeah.
being generated.
Okay, so here's the third. If I came over here and then drop this down to a couple over here,
You see that
it's
some of those
starting to delete
resources are
them.
being destroyed. So it's reevaluated the cluster, determined it needed to pull those machines resources out, and shrunk it again.
So what would happen if I'm having trouble with this? How would you know?
Well, we have full administrative and operational control overseeing these values. You can look at the activity job logs to determine what's happening in those job logs. So
Okay.
if something's breaking in the system, there's some connectivity issues or external factors causing problems, we'll see those raised within the job logs.
Okay, so if I drop this back down to say 3, you come over in the job logs. Oh yeah, you can see there's a
them
whole
running.
bunch of action, and you could
Correct.
help me figure out what's going on.
This is very nice from a audit control perspective as well. If you need to ensure that you're not over consuming resources, for example, if you're running this against public cloud resources and those are very expensive, you might want to be able to determine who's doing what and when, and be able to verify and account for those appropriately in whatever your business processes are.
That's cool. That'll encourage my team to not leave big clusters running because it's so hard to get approval to get a big cluster.
Don't tell the cloud providers that.
Okay, well that's a helpful thing. And then when they're done, I wired in this just cluster cleanup. So I called the API. Over here, I know that in this API, I can go in and click here and then just say delete. And then does delete then take out those machines?
If the cluster is reevaluated with the cleanup process as the definition for it, then yes.
Okay, so this literally is going to delete the machines when it's not going to leave those orphaned
Correct.
here? Okay, so if I come in and say third, deleting it, check in over here. Let's see what's happening on third. Oop, third's already gone. And
third has been cleaned up.
Third's cleaned up, and then there's no third machines in my machines list. Okay, so the same thing true. I could come in and take out my sample machine, and it's already deleting the machines out of the system.
Correct.
So here I've been able to take a IDP, provide really simple interfaces that are very constrained for my users, and then on the other side of it have really nice operational controls.
Correct.
And it doesn't have to be Backstage here.
It can be any IDP,
anything.
any portal that can talk to an API service.
Cool.
Yep.
What does if someone wants to adopt Digital Rebar in their environment, what does that on-ramp process look like?
Fairly straightforward. We very much encourage a self-trial process with our customers, and we enable self-trial download and use of the platform. From a resource perspective, it's very straightforward, a Linux system of some sort. Typically, most of our customers will have either a dedicated bare metal machine or a virtual machine within a hypervisor cluster of some sort that they can spin resources up. If you want to play with the platform from a just understand it perspective and you're not driving physical resources on-prem, we can spin those up as demos within the cloud. You can play with the ERP endpoint itself in the service, understand our infrastructure as code story, understand our multi-site management capabilities, and then we can destroy those resources again. So there's a couple of different paths you can take towards that.
And if you're working like multiple teams in an org, then it's very easy to build your own Digital Rebar. You don't have to fight somebody else to get access to theirs, but then bring in whatever content packs or things they've developed.
Okay.
So that's part of the design here is the teams don't have to like have one server and then fight over it. It's actually designed to have people working independently and then collaborate on the automation.
What about the import process for existing virtual machines and bare metal servers and all that jazz? I'm going to have stuff.
Yeah.
So,
Yeah.
There's a join up process that can create machine objects for implementing control over them. The join up process is sort of two-part. You need a machine object that represents the thing you're managing. We have cluster objects. We have a couple other types of objects, but generally speaking, it's a machine object, whether it's a network switch, it's a software-defined storage platform, or it's a server. It can be even backed by a container running the second part, which is a runner service. That's the DRP CLI is also an agent that provides the runner service. So that was going back to your question earlier about the graph control and parallel operation. Because we have a runner service in place, you can run multiple operations in parallel. And so abstracting from infrastructure and just going into control aspects, you can run clusters of containers, which is actually the demo we just showed with Backstage, is creating a cluster using backing containers as the runner services to do some workload. So those are not real machines, as I would call them, virtual machines or physical machines.
But if we change the context, they would have been.
They can be as well. And then also they give you a place where you can do API interactions with the rest of your infrastructure. So this comes back to a story with one of our financial sector services company that wanted to do the audit of the baseboard management controllers. They wanted to audit 200,000 physical machines in a weekend. That's a heavy workload for any application stack. To be able to do that, we can spin up tens, hundreds, thousands of containers and parallelize those operations through a batch management process. And then you can control the queuing size of how fast the batch releases work orders and then executes that against the infrastructure. So we can do some very interesting parallel operations.
And in those cases, we can create the machine objects, collect data about them without ever actually logging into the machine or having a join up or a run. And then when the machine reboots, or if we one day get control, we have a fingerprint for the machine, we'd match it, and then we'd align that information. Like we have customers who take shipping manifests, import the shipping manifest, and then when the machines boot for the first time, they look up the manifest and match
They already have that
correct
populated.
Whatever their
and then they have to hook
infrastructure service.
into whatever BMC is on the.
It'll actually, it'll hook in all that, but actually the manifests, they add in all of their other configuration data. So the machines come in, they validate the manifest is correct, then they start looking up data out of that file to set all of the out-of-band management, everything. They like literally deep scan, validate the machine against the manifest, and then complete the configuration because it's declaratively said, I want you to be this, and it just starts down that process.
Okay.
Question. Well, two. One is that Lindsay Wagner.
Yes.
Okay. Second.
Very important.
There's an AI reference in this to another presentation that I didn't have time for about the bionic dog.
Second, after all this building of, or virtually building of real infrastructure, can one of those steps be the putting an OS on that thing, like from an image that I have? Is that?
Yeah. From an OS deployment perspective, we support two primary paths: the standard Kickstart network scripted path, Kickstart pre-seed, auto install. The other is you can create single artifact images, very much like a cloud image, like an AMI or a VMDK, QCOW2. We can create images for bare metal infrastructure as well as virtual infrastructure to apply that single image. That is actually my preferred approach because it's an immutable infrastructure. You can test and evaluate that image, harden that image, and then deploy that image. Some of the things that we've talked about through today's demos is the ability to customize on top of that. So you can deploy that hardened image and then customize on top of that hardened base.
So deploy the image and then tweak that particular OS for
Application,
whatever you need to do.
Install, config, yes.
We have, a lot going on with this. I would encourage you to check out some of the previous Cloud Field Days where we go into the architecture more. And if you have questions or want to play with this, please visit us at RackN. We're always happy to help.